Problem 1. It says find the magnitude and direction of the resultant vector if V is 120 newtons at 65 degrees and U is 85 newtons at 30 degrees. If we draw them geometrically, we start with a horizontal line. You draw your 120 at 65. You draw a horizontal here, measure 30, and my resultant is here. What I'm going to do is find the components of this one and the components of this one. So here's x component and the x component. Add them up. It will give me the resultant x. And I do the same thing with the y here and the y here. Add up to the y for the consultant. So here's the y of the two vectors. I use I and j to remind me that I is in the x direction, j is the y direction. In order to find the magnitude, I have to take the square root of the x squared and y squared, a squared plus b squared equals c squared, and I end up with 195.795 newtons. In order to find the tangent, you do the inverse tan, there's no equal sign there, of 151 over 124, it gives me 50 degrees. So therefore my resultant, when I got done, this is 195 newtons, and this is 50 degrees. Now of course you will carry everything to 3 places, it's just too hard to write that way. Example 2. An airplane flies due west at 350 miles per hour. This is west, 350. And the wind blows due north at 20. You connect it to this end because when you add vectors, you connect the second one to the end of the first one. My resultant will be here. You'll note that this is a right triangle, so use the Pythagorean theorem because it's easier and you don't need to deal with sines and cosines. So a squared plus b squared, 20 squared plus 350 squared, equals 350.57 miles per hour. When you do the inverse tan of 20 over 350, you get 3.27. Now remember that you have to qualify that as being northwest, because that's this angle, or subtract it from 180, so you have 176.73 degrees. Example 3. Given two forces, 28 newtons at 42 degrees above due west and 48 newtons at 32 degrees above due east, find the magnitude and direction of the resultant vector. First, draw your picture. This is west, so my 28 newtons is here. This is 42 degrees. 42 degrees. Can't write very well. And there's 48 newtons at 32 degrees above due east. The first thing I want to do is change 42 degrees to 138, so it's measured from standard position. So I'm going to go from here to here. I need to do that because if I take the components of the vector with 28 Newton force, this x value is negative, and the cosine of 138 is also negative. Then I plug it into my formula, 48 times the cosine of its angle, 28 times the cosine of our new angle. That'll give me the I component, 48 times the sine of 32, 28 times the sine of 138, gives me the j component. To find the magnitude, remember you take the square root of x and y squared. And I end up with 48.447 newtons. To find the angle, you do the inverse tan of 44.172 divided by 19.898, and you get 65.75 degrees. Be sure to ask yourself which quadrant you're in. And since both the x value is positive and the y is positive, I'm in the first quadrant, and 65 degrees is a good answer. Example 4. Twins Mo and Joe are pulling a wagon down the street. Mo is pulling with 48 pounds of force and Joe is pulling with 26 pounds of force. The angle between the ropes is 33 degrees. What is the resultant force in the direction on the wagon? Since we don't know which direction they're pulling the wagon, we pick one force and make it 0 degrees. If this is the wagon and one's pulling this way, and one's pulling this way, we know this is 33 degrees. We don't have any reference point, and that's why we pick one of them and put it at 0 degrees. In this case, I picked 48 and made it at 0, and using my adding vectors geometrically, the angle here is 33 degrees, and I draw the second one. So my resultant goes from here to here. And now I set it up, 48 times the cosine of 0, 26 times the cosine of 33, it gives me 69.8. 48 sine of 0, 26 sine of 33 gives me 14. To find the magnitude, remember you're going to take the square root of x squared plus y squared, and you get 71.227 pounds. When I do the inverse tan, you have your y over x, I get 11 degrees, but I have to qualify it. You have to say it's away from the 48-pound force. You could work this problem making the 26-pound force here and this 48. You'll get the same magnitude for the resultant of 71 pounds, but this angle will be 33 minus 11 because the two of them add up to 33. Example 5. A 300-pound box lies on a ramp that makes an angle of 20 degrees with the horizontal. So here's my horizontal, here's the ramp, 20 degrees, my box, 300 pounds. A rope is tied to the box from a post at the top of the ramp to keep it in position. So here's the rope, here's the box. It says, ignoring friction, how much force is being exerted by the rope? Well, first off, gravity's pulling down on that box, that's why it weighs 300 pounds. This is a vector, which is made up of two components. You have the vector that's perpendicular to the hill and the vector that's parallel to the hill, and these two components make up the 300 pounds. This is a right angle. This is 20 degrees. This angle right here is also 20 degrees. They're looking for this force because the force going down the hill has to be equal to the force going up the hill in order for the box to not be moving. So all I have to do is take 20 times the sine of 30, good old SOHCAHTOA, opposite over hypotenuse, and I get 102.606 pounds is what's holding this force on the rope.